Hi, my name is Avery, and today I'll be introducing the Cigbot. Now, whenever I travel to different cities such as Toronto, I notice that there always seem to be cigarette butts on the ground outside almost any building and on the sidewalks too. In fact, I did a bit of research and found out about this. On the left is the CN Tower, which weighs about 130,000 tons, while on the right is cigarette butt litter. Note that about 845,500 tons of cigarette litter is dropped on the earth each year, which equates to almost 6.5 CN Towers of just cigarette butt litter. So, I noticed that there was actually a huge problem with cigarette butts being tossed onto the ground. They pose a threat to the environment, leaving heavy metals and other unwanted chemicals on our earth. Though one or two may not be a huge threat, the fact that cigarettes are the top plastic polluters and make up to 50% of the litter in cities such as Hamilton is dangerous. Current methods of trying to resolve this issue have cost other cities such as San Francisco up to $6 million per year. This is why we created Cigbot. Our Cigbot is basically Wall-E, a robot that collects and disposes trash, but with a special focus on collecting cigarette butts. Its mission is to rid Earth of litter, and to start, its goal is to collect and properly dispose of the 4.5 trillion cigarettes that are discarded improperly each year worldwide. We have three main functions. Cigbot will autonomously roam the streets looking for cigarettes. When it detects one, it processes the location of the cigarette. It then drives over and uses a roller mechanism to effortlessly collect, smother, and dispose of the cigarette.
As you can see here, the robot works by using the camera to go towards the locations of the cigarettes, and then it drives forward collecting them. It will take some time to process their information and just verify they're there. In this demonstration, we collect 4 cigarettes, all arranged in a straight line of sorts. And yeah, it's everything in action.
Cigbot uses machine learning and image recognition to determine what waste is to be picked up within its vicinity. This is paired with pathfinding algorithms that guide Cigbot to the litter and collects it using its sweeper and storage systems. Now let's introduce our team. Avery is our firmware developer, Chelsea is our software developer and designer, Ariel, our assistant designer, and last but not least, David, our mechanical designer. Together, we designed, built, and devised a plan to produce the Cigbot you see here today.
I'm sure you're wondering, how did you do it? Cigbot was created using many different technologies that work simultaneously together. Mask RCNN was used for object detection and segmentation, while Python interfaced with the Raspberry Pi to run the machine learning model. We also used TensorFlow to process the data for the pre-trained model, and an Arduino to control the motors and sensors being used, which include VEX motors, a Raspberry Pi camera, and a wide-angle USB webcam. SOLIDWORKS aided us in CADing 3D models of the Cigbot and creating mounts for the electronics through 3D printed parts.
On the mechanical side of things, Cigbot is made up of VEX parts, 3D prints, a sweeper mechanism, and multiple sensors, motors, and microcontrollers. Together, these parts make up the Cigbot you see here today. Building Cigbot did not come without its challenges. Due to our team's different living situations, we had to work remotely for the majority of the 2 weeks. This made designing, collaborating, and transporting supplies difficult. To overcome this obstacle, we split up the tasks so we could work independently and organize times to drop off or pick up needed supplies. The design of the Cigbot also proved to be challenging. Certain mechanics, such as the sweeper mechanism, had its obstacles. To conquer this, we would have designated brainstorming sessions where we would discuss potential solutions to our problems. We also had issues with shipping. From the start, a few of the parts we planned to obtain had shipping periods that exceeded the amount of time that we had for the hackathon. Whenever shipping was an issue, we would talk over different alternatives and create plans around this inconvenience. Cigbot is a multidisciplinary robot and qualifies for 3 of the hackathon's categories: environmental sustainability, smart city automation, and best unconnected hack. Cigbot helps the environment by ridding it of the toxic substances of cigarettes, which also coincides with waste management in the city. This is all accomplished without using any form of wireless connection. Our team believes Cigbot has a lot of potential. However, due to time constraints, we could not do all that we had hoped. Cigbot was designed to eventually recognize other types of trash so it could make the city even cleaner. We would also love to give our robot some upgrades so it can explore different terrains and execute beach and park cleanups. Another improvement for Cigbot would be to create anti-theft capabilities to ensure components of the robot or the robot itself cannot be stolen. We would also love a robot to be running in all weather conditions so Mother Nature cannot stop Cigbot from working hard.